For goodness sakes, I forgot to go back and show you StatCrunch. So I will do that real quick. Let's see. Lord have mercy. This is the problem that will never end. So you'll need all of this information written down. And once you get all of this information written down, you can then jump on over to StatCrunch. Should give you the same information. So let's go back over to StatCrunch. By the way, that last problem where we just found using the table, we have a z-score. Remember, the z-score was negative 2.98. So you put that z-value in there, and it gives you, so you can see it's way, way, way over there, 0.0014. So that was the area, and this area is obviously less than that 2.32 area. So there's that area. Now you can do a hypothesis test. You should kind of remember this from when we were doing when we were doing confidence intervals. So you just go to stat, and we're using z values. So you go to z stats, you do one sample, because we only do one sample in this course, and we're doing summary information. We don't have a list of numbers. So there's the options that you pick. Like I said, that's the same options that we did with confidence intervals. We get the same thing with confidence intervals, except this time we're going to do hypothesis test. So what was the sample mean? That was 12.9. The standard deviation, and of course they're talking about of the population, because that's why we're using a z summary, because it's population standard deviation. And then the sample size, it was 32, wasn't it? 32. Okay. Now, remember, the null hypothesis always contains equality. So don't worry that it's equal right here, rather than greater than or equal to. They're not going to put that symbol here. We'll worry about the symbol of down here in the alternative hypothesis. So all you have to do right here is put this number right here, whatever this number right here is. So see, we have equal to 13. See, we are actually saying that the null hypothesis is equal to 13. It's just not just equal to 13, but greater than equal to 13. But like I said, we'll fix that when we go to the alternative hypothesis. So the null hypothesis is always going to be equality. So we're going to put the 13 right there. So we're going to type in 13. And then down here, you tell it that the alternative was less than. And I think, let me see. The alternative was less than. Now I thought I remembered. So since the alternative was less than, then on this screen right here, for the alternative, you put less than. And we're not doing a confidence interval. We're just doing this. I don't like it to store the data in the table. I like it to give me the answers, and we'll see what it's going to do. We'll plot it. I don't know what the plot was going to look like. So let's compute it. All right. So here it gives us our test statistic. Remember, this is a hypothesis test. So there's our test statistic, negative 2.98. Remember, that's what we got right here. 2.98. We got that right there. And then they're also showing us our p-value. And our p-value, they have 0.0015. That's just a round off error, but that's okay, because 0.0015 is still going to be less than 0.001. So even the round off error doesn't matter. So we got our p-value right here, 0.0015. We would say 0.0015 is less than 0.01. So we got the number that we would plot to use the rejection region, and we also got the p-value that we would compare to alpha. So StatCrunch is going to give us both of these things right here rather quickly. So we're probably going to start our next problem with StatCrunch. Let's run down here and do it real quick. So where are we? We just finished that problem right there. Okay. So we are a homeowner claims that the mean speed of automobiles traveling on their street is greater than the speed limit of 35. Okay. So there's our claim. Okay. We've got our claim right here. Claim that the mean, there's the average, is greater than 35. Okay, so let's make some notes. Our claim is that the mean is greater than 35 miles per hour. That's our claim. Does this statement right here contain equality? Does it say is 35 and greater? No, it does not. It just says it's greater than. So that means since it does not contain equality, this is our alternative hypothesis. Okay. The opposite of going greater than 35 is going less or equal to 35. And that contains the equality. So that is our null hypothesis. We look at this right here to determine what kind of test it is. It's greater than, so we know it's a right tail test. Okay, now we're going to continue the problem. A random sample, there's the word random, of 100 automobiles. So my sample size is 100. I don't have to worry about it being normal because it's greater than 30. So it's going to be normal. The sample has a mean. So that's the sample, the mean of the sample. The sample has a mean of 36. Assume there's the keywords right there. Population, standard deviation. There's population standard deviation. There's the key word. So that's how we know we're going to be using z values right here. And none of this will change when we do t values. None of that. We wouldn't have had to read that first. We can do that. It doesn't matter if it's a t, a z, or a p. You can do that. It's when we actually get ready to do the test that it matters. So the sample size, the mean of the sample. This is how we know that it's going to be a Z test, a Z hypothesis test. And our alpha is 0.05. And they want to know, can we support the claim? So I'm going to draw my picture. Draw my normal curve. I know it's normal because my sample size is big enough. It's a right tail test, so my area is going to be over here. Okay, that's where my area is. My curve is really ugly, sorry. And so I need to find my the z value for my confidence for my critical value. Could not find my word. So I need to find my z value for the critical value. This alpha right here is 0.05. Okay, so I'm gonna go to StatCrunch right now and start with finding my z-score. So I'm gonna close that. I'm gonna go to Stat, Calculator, Normal. I have an area, but it's greater than, and it's 0.05, and I want to compute the z value. So my critical value is Z is 1.645. So I have that is 1.645. That's the wrong one. My Z value right here is 1.645. Now I'm going to go to StatCrunch and put all of this information on the StatCrunch calculator. Remember what we did? We do stat. This is a Z thing. So we do one sample with summary. I'm looking at my notes. So I wrote down that the mean was 36. The standard deviation was 4. The sample size was 100. And we're doing the hypothesis test. And the one that contained equality was equal to 35. Your alternative was greater than this time. And I forgot, I never did look at the plot a while ago. So I'm going to compute it. And now it gives me my test statistic, which is 2.5, and my p-value, which is 0.002. So I'm going to jot those down on my paper. My z-score is 2.5, so I can see if that's in the rejection region. And then I can compare 0.0062 as my p-value, compare that to my alpha, and determine whether or not I reject or fail to reject. So I'm going to go back over here. Okay, so let me change colors here. StatCrunch told me that my Z was 2.5. So 2.5 is going to be way over here. If this is 1.64, 2.5 is going to be over here. That's my test statistic. So it's in the shaded region. Anytime it's in the shaded region, we reject. And remember, we always reject we're always testing our null hypothesis. We reject our H sub O. We can also determine that we're going to compare our P to our alpha. Our p-value, remember this was on StatCrunch. StatCrunch said my p-value was 0.0062. My alpha is 0.05. Now, what symbol goes in between those? You always write the p on the left, the alpha on the right. This number right here has a 0 in the second spot. This number has a 5, so this number is smaller. And if it's less than, it involves the thing. And so this also says we reject H sub O. And if you're wondering where I got that from, I got it from right there. When P, which was 0.0062, is less than 0.05, then we reject H sub O. Okay. Now I need that little, I need this little thing right here. Copy it. Come over here and paste it so I can look at it. We'll paste it over here. Okay, so what this time our claim was the alternative. The claim was the alternative. So I'm in this column and we reject our H sub O. So you're going to write this fill in the blank sentence. So how does it go? There is enough evidence at 5% significance level to support the claim that cars go more than 35 miles per hour. Yeah, that's good enough. Okay, so there is enough evidence at the 5% significance level to support, and we got all of that from here. Is enough evidence to support, and then you state the claim. All right, there's that one.